with the help of labels which is available, and it will give you the output. So whenever you are giving new input to the model after learning, model should depict the apple as an apple, banana as banana. So this is called supervised learning. Okay, when we're talking about unsupervised learning, now we can see a kid grown up a little. Okay, and he learned everything regarding addition, subtraction, and all in under the supervision of teacher. Now he grown up a little, and now he can do all the addition, subtraction, and the small tasks without the supervision of teacher. So when you are doing, when your learning will be done under no supervision, then this type of learning is called unsupervised learning. So we have discussed many algorithms under this, like clustering algorithm and association algorithms. We learn under unsupervised learning. So we discussed all these things in the previous 4 units. Now we will talk about reinforcement learning. So reinforcement learning is nothing but we are trying to establish or encourage the pattern of certain behavior, or we can say a person or a student or a kid will learn with their own mistake. Okay, so that is nothing but your reinforcement learning. We can take a simple example. Suppose you land on a isolated island because of some reason you landed on some isolated island, so you don't know what to do, how to what to eat, where to go, where not to go. So what you will do, you'll get a panic, but slowly you will learn how to live there and you will adopt the climate, the food and the changes. You will understand what should I eat and what should I not eat. So you have learned through your own mistakes. So this is nothing but a wait and trial method. So if you remember the Candy Crush game which everyone have played, I think. So what will be there in the Candy Crush game? You will get a, if you have done the if you have done the taken the proper action, you will get the candy, otherwise you get the punishment. So this is same like, so you will learn, your learning will be through your hit and trial method. So this is another way of learning. So you will learn from your own experiences in the case of reinforcement learning. Okay, so now we'll discuss in detail about reinforcement learning. So reinforcement learning is a type of machine learning where agents learn to behave in environment by performing action and seeing the results. So in the previous case, when we have taken the example of island, so what is environment here? The island is nothing but the environment, and the person who landed on that particular island is nothing but the agent. So agent who stuck in the island within that particular environment. So environment is nothing for me, within the island. So we are providing some certain action and try to discover what I should eat, what should I not eat. So using my error or you can say hit and trial methods, I'll get either reward or I'll get the punishment. So this is nothing but the reinforcement learning. So reward or punishment will be taken as per your actions. So is nothing but it's a type of machine learning where an agent learns to behave in environment by performing certain action and accordingly it will get the results. So we'll try to understand this again with a small analogy so it will be better clear for you. You can see here there is a baby who just started crawling and he saw the candy in the box. Okay, so he started crawling and he just started crawling and he want to eat those candies because it looks so attractive. So he want to go and eat those candies. So he will start crawling from here to there. So you can see here there are some hurdles in between. So if the kid will cross all the hurdle without any problem, then definitely it will reach to the candy and obviously baby will eat the candies. So what is reward here? Candy is reward. Okay, candy is reward. So when he is going to get the candy, then he will perform a proper action. So if he will walk properly, if he will crawl properly without facing these hurdles, and he'll reach to the near to the box where candies are available, then definitely he'll get the reward in terms of candies. So this is one scenario. What is the second scenario here? Second scenario, when baby start crawling but falls due to some hurdle which came in between. So suppose again baby started crawling, but because of this hurdle, he fall down and he start crying. So definitely he will not get the candies. So there are two scenarios here. One scenario where baby is crawling and he reach to the candies and he'll eat the candies. The second scenario when baby have taken some actions but he did not reach to the candy and he start crying because he fall down. So now the question is, what is agent here? We know that in reinforcement learning we'll be having agent and environment. So baby is agent here. The environment is nothing but the room. This is the room which we call it as environment, and candies are nothing but the reward which baby is getting. So I hope it is clear to you. What is reinforcement learning? So how baby is going to learn? Baby is going to learn with their own mistakes. But if baby hit at this particular object, he fall down. So next time what baby will do? Baby will cross this object in different ways. So he learned from his own mistake, and next time he will not fall down. So this is nothing but hit and trial method which we are using in reinforcement learning. So as I hope it is clear to you that what is the reinforcement learning process is. So we understood that reinforcement learning system is comprised of two main components. One is agent and another one is environment. So what is agent? If we take the example of previous one, where we said that baby is nothing but for me is what? Baby is an agent who is performing certain action. And what is the environment? The environment is nothing but the room where baby is playing. That room is nothing but an environment. So we are keeping an agent into a unknown environment. Agent don't know about that particular environment, and he's going to use second trial method to figure out the environment and then come out with some outcome. So if we figure out the environment and he'll get some outcome, means he'll get some reward, otherwise he'll get the punishment, and finally it will reach to the destination. So in our previous example, baby was agent and candy was reward, and room is nothing but is an environment for me. So agent is nothing but reinforcement learning algorithm for us. So whatever reinforcement learning algorithms are there, those are called algorithms. Okay. So when agent will complete the task and get the final reward, then that state will be terminated. So that state is called terminated state. And agent will perform some policies and some actions also here, which we'll discuss further. So before going further in more detail about detailed terminology of reinforcement learning, we'll take one more example so that your understanding will be more better. So as I hope everyone plays the Counter Strike game here. So when we play the Counter Strike game, we don't know where to go, what to do, where to shoot and where to move. So that is an unknown environment for me. So you are an agent, you are a person who is playing the game. So you are an RL agent who is in state S0. In the beginning state, we are saying state S0 in that particular environment. So based on your state, the RL agent takes the particular action. You will take particular action. You will go to a certain direction randomly. You don't know where to go, where not to go. You will take some action randomly. Okay, and you will reach to the new state. If your action is proper, then you will action is proper or not proper. You will reach to the next state. If your action is not proper, you will go to the beginning. Means you will fail. If your action is proper, then you will go to the next state. You will go to the next state. RL agent now, if you will go to a proper direction, then you reach to the next state. It means you will get the reward R1 from the environment. Okay, the reward we are taking it as R1. So you will get the reward from the environment, and this will goes on until the RL agent will not reach to destination or you will not die. Okay, either it reach to destination or you will die within the environment in the case of Counter Strike example. So every time you are taking some action and you are reaching from one state to another state. So if your actions are proper, you are going to get the reward. If your actions are not proper, you are going to get the punishment, and this will goes on until you will not die or you will not reach to the certain destination in the case of Counter Strike example. So I hope it is clear to you. Now there are some definitions which we are having in reinforcement learning. So as we discussed, we discuss about the reward. Reward is nothing but an instant return from the environment to appraise the last action. So we have taken the example of Counter Strike. So if your move is proper, you will move to state one to state two. Then definitely you will get some rewards. You will get some badges. So that is nothing but rewards for me. Next is policy. Policy is nothing but the approach that agent used to determine the next action based on the current state. So it's a strategy we can say that the agent uses to find out the next action based on your current state. So what policy you are using to grow from what policy you are using to determine the next action as per the based on your current state. Now next terminology is value and action value. So value is nothing but the expected long-term return with discount. It is just opposite to the short-term reward R. Action value is just similar to value we can say, or we can say it's a little difference because we are taking here extra parameter which is a q value parameter which is used for the current action that found the q value depend on the action what you have taken. So value and action value we'll discuss in more detail in the next class. So I hope the basic terminology is clear to you. Okay, and this already we have discussed what is agent, environment, action, and state. Agent is nothing but the RL algorithm that learns from hit and trial. Okay, the agent in the case of in the first example, baby was the agent. In the second example, we have taken island, so you were the agent. A person who landed on the island, that person was the agent. And in the case of Counter Strike, is a person who is playing the game, he's the agent. So in the case of reinforcement learning, the RL algorithm is the agent for me, which is learning. Good morning, students. In today's class, we are going to discuss about reinforcement learning. So, if you remember in the previous session, we have discussed the basic concept of reinforcement learning, where we discussed about what exactly the reinforcement learning is, what is state, what is agent, what is reward, what is value, and what is Q value. So, we discussed all these basic concepts, and now we are going in more detail about reinforcement learning. So, we are going to discuss a concept which is called reward maximization. So we are taking a simple example here, and with that we'll try to understand what exactly the reward maximization is. So as you can see in this figure, we have a fox, we have an tiger, and we have some meat chunks. So here fox is behaving like an agent, and tiger is an opponent to the agent, and there is a reward which is nothing but a meat chunks. So what is the scenario here? The fox wants to eat the meat chunks. So some meat chunks are in the smaller in the size and some meat chunks are bigger in the size. Now the question is which meat chunk fox has to eat? A smaller size of meat chunks or a bigger size of meat chunks? So you can see here there is a tiger. So whenever a fox will try to come near to the tiger, there is a possibility the tiger will kill fox. So there is lot of risk involved in this, and there is a possibility that whatever chunks are available near to the fox, they are bigger in size. So if fox will try to eat those meat chunks, then definitely there is a possibility, or we can say there is a risk that maybe tiger will kill fox. So now the question is which particular meat chunks fox has to eat and which fox has to avoid. So if we are talking about the meat chunk which is near to the fox, just here, so you can say it's very near to the fox. So definitely there is a risk, very less risk is involved. So this is the first reward what fox will get in terms of meat chunks, and fox will eat easily. So now the question is we need more reward or we need less reward. So there is a concept called reward maximization. So we have a theory that when we are in a particular environment and whenever we are working on reinforcement learning, the reward, we will always try to maximize the reward. So our reward maximization theory states that the RL agent, where the RL agent is fox, must be trained in such a way that whatever action agent will perform, each agent should get the maximum reward. So that is nothing but we'll call it as the reward maximization. So that reward which are near to the tiger, and if they are big and still fox is not ready to eat. So that is called discounting. That concept is called discounting. Because if there is a possibility that whatever meat chunks are near, whatever meat chunks which are near to the fox, but it will be maybe near to the tiger also, and if it fox will try to eat that particular meat chunks, there is a possibility that particular tiger will eat the or kill the fox. So there is so will discount such type of rewards. So will not ready to take the risk. So this concept is called discounting. So discounting of reward work based on a particular term which we'll call it as gamma, which we'll discuss later. So now you try to understand what exactly the reward is and what is reward maximization. So reward is nothing but whenever you'll perform some certain of action in a particular environment and those actions are proper, so you will get the reward, otherwise you'll get the punishment. And our RL agent should be trained in such a way that the reward should be maximum. Clear? Now, what is reward function? The reward function is nothing but it is an incentive mechanism that will inform the agent that what is correct and what is wrong using reward and punishment. So you can see here, we have discussed that when a fox will eat a meat chunk which is near to the fox, so definitely that will be incentivized because it's near to fox and fox will get the reward. But if fox will try to eat the meat chunks which is near to the tiger, so definitely there is a possibility that fox will get the punishment. So our goal of our RL agent is to maximize the total number of rewards which are available. But sometimes what we have to do, we have to sacrifice the immediate rewards in order to maximize the total reward. So what we have to do, if I want to maximize the total reward, so what I have to do, I have to take the risk in this particular factor so that avoid I can avoid the very next available rewards. Sometimes I have to avoid, but sometimes we will take very next reward as well as we will try to maximize the reward as per the action what we have taken. So this is nothing but your reward function is. So now the question is what is discount factor? So as in the previous example we have discussed that there is a fox and there is a tiger. So if meat chunks are near to the tiger, so the fox is discounting that particular meat chunk because there is lot of risk is involved in that. Because of risk, the fox is not going to eat that particular meat chunk, and you are trying to improvising your task, and you don't want to take that particular risk. So this particular concept we are calling it as discounting. So discounting of rewards work on a term which we'll call it as gamma. So we have a terminology which worked in terminology which is called it as gamma, and the gamma value will lie between 0 to 1 as it is written. So when we are talking about this, so we can say that smaller the gamma means the larger the discount value is. So whenever we are talking about the discount factor, we have a gamma, which is the real value between 0 to 1, and it cares for the reward agent achieved in the past, present, as well as in the future. Or we can say in a different way that it relates the reward in a time domain, because we are talking about the reward which is taken in the past as well as present in the future. So discount factor works in the time domain. So if I'm saying that rewards will be between 0 to 1. So if gamma value is 0, it means gamma value is 0. It means we are only caring about the first reward only. We are not caring about the future rewards. We are just caring that whatever the very first reward I'm getting, it is a big reward or not. Okay. So if I'm caring only the first reward, then gamma value will be 0. And if my gamma value is 1, it means the agent is taking care of all the rewards which he is going to get in the future also. So gamma, if gamma value is smaller, means gamma is near to 0, or we can say if gamma is smaller, it means the agent is not going to explore the environment. Whatever the first reward agent is going to get, it will take that particular reward. So in that particular way, the gamma value will be smaller and it's not going to take any risk. So in the case of our previous example, that fox is not going to take any risk and it will never go near to the tiger. Whatever meat chunk is available near to the fox, fox will take that particular meat chunk, and in that scenario, gamma will be always 0 or near to the 0. When I'm saying my gamma value could be 1 or it can be near to 1, it means agent is ready to explore the environment and try to eat the meat chunks which are closer to the tiger. Means agent is not satisfying with the first reward what he is getting. Agent is trying to explore the whole environment and try to get the meat chunks which is near to the tiger. So these meat chunks are near to the tiger and maybe these meat chunks are bigger in the size. So if this fox is trying to eat the chunk which is near to the tiger, it means gamma value will be near to 1. If the fox is trying to eat the meat chunks which is very close to it or very first reward which fox is going to get, in that case gamma value will be always near to 0. So the reward maximization, or we can say reward will be maximum in the case when you are trying to explore the whole environment, and for that, we are using the concept which is calling it as discount factor. So I hope it is clear to you. Now I have used the terminology exploration. So what we are saying here, the agent is trying to explore the environment. So what is environment here? In this case, this particular cubicle, these cubes are nothing but the environment for the fox. So if fox is ready to explore this environment, so this is called the exploration. So if you remember in the previous session, we have discussed the concept like a baby is in the room. So that room is the environment for the baby. So when baby is trying to explore the whole room, so that is nothing but we'll call it as exploration. So whenever we are talking about reinforcement learning, we should always remember the two concepts. One is called exploration, another is called exploitation. So these are very important terminology which we'll use further also. So what is exploration? Exploration is nothing but it is about exploring and capturing more information about the environment. So as name suggests, exploration is nothing but capturing more information about the environment, where agent is trying out new action and state to discover their potential rewards. Agent is ready to explore the environment to get more number of rewards. So if agent is ready to explore, so it helps the agent to gather more information about the environment, and there is a possibility that it will include rewards as per their action. So if agent is ready to explore, the agent can find the better strategy or better policy and avoid getting stuck in a particular solution. Agent can have a better solution. If I'm ready to explore different way of performing a task, so definitely there's a possibility I'll find the best way to solve that particular problem, like how you will play different mobile games and you will try different hit and try method, because you want to explore the environment. So if you're exploring the environment, there's a possibility that you get the better solution. Okay, so this is called exploration. When we're talking about the exploitation, exploitation is nothing but it's about using the already known exploited information to heighten their rewards. It means agent is using only the known information. Agent is not ready to explore the environment. Whatever information agent knows, accordingly, agent is trying to get the highest rewards. That is called exploitation. So exploitation involves the agent using its current knowledge to choose action that it believes will lead to the highest reward. So whatever current knowledge I'm having, according to that, I'll perform some action and I'm trying that I should get the maximum reward. So that is nothing but exploitation. And it will allow the agent to maximize its rewards based on what he has learned so far. So as for the learning, he's trying to get the maximum reward. So using exploiting, the agent can quickly improve its performance and familiar situations. That is the benefit of using exploitation. Performance and exploiting, the agent can quickly improve its performance. So using exploiting, the agent can quickly improve its performance and familiar situations. That is the benefit of using exploitation. But the problem with exploitation is it will too much rely on the exploitation. Maybe it will prevent the agent from discovering better action because you are not ready to explore the environment. Whatever knowledge you have gained from your previous action, you are trying to use that knowledge and you are trying to get the maximum rewards. There is a possibility maybe you are not able to discover better action, and there is a possibility maybe you will not get the potential reward which you would have what if you would have performed exploration. So that is the basic difference between exploration and exploitation. So I hope it is clear to you what is exploration and what is exploitation. So just to summarize that what we have discussed. So when we are talking about the RL agent, what he will do? RL agent learn from the consequences of its action. As we discussed, that we have written by method. So agent is ready to learn from its action rather than from being explicitly taught. So there is no supervised learning available here. Agent is learning through mistakes. So there is no explicitly training will be given to the RL agent, and it selects its action on its past experience, which is nothing but exploration, as well as it can perform new choices, which is called as exploration. So agent have two options: either it can explore the environment, it can perform different actions, or agent can use the previous experience, that is nothing but exploration. And this whole strategy we are calling it as trial and error learning. So whenever we are talking about reinforcement signal, that RL agent receives is a numerical reward. So whenever you're talking about RL agent, whenever you're performing a task, and if your action is proper, then you will get a numerical reward, which encodes the success of an action outcome. So if you will study, you will get the marks. The same way, if you will perform a proper action, you will get the rewards in terms of numerical value. And the agent seeks to learn to select action that maximize the accumulated reward over time. So our main goal is to try to maximize the reward using certain actions performed in a particular environment. So this is all about your exploration and exploitation, and we discussed about the discount factor also. I hope it is clear to you. Good morning, students. In today's class, we are going to discuss about Markov decision process. So, what exactly the Markov decision process is? It is a mathematical approach to mapping a solution in reinforcement learning, we can say, or it is a way that the purpose of RL is to solve the Markov decision process. So, it's a mathematical framework which is used for decision making in the situation where our outcomes are partially random or they are under the control of under the control of decision maker. So, whenever we are talking about any reinforcement learning mechanism, our main agenda is to maximize the reward, and we will follow certain policies to maximize the reward. So what we are trying to do, an agent is supposed to decide the best section and select best section to select based on his current stage. So our main aim is agent has to take some certain action so that it can move from one state to another state, and the reward should be maximum whenever it's changing the state. And these steps should be repeated, and this particular problem is known as Markov decision problem. And this Markov decision process is widely used in various tasks like robotics, economics, artificial intelligence, especially in the reinforcement learning. So our main goal of this particular Markov decision process is we are trying to find a best policy which will give the maximum reward over the time. And we are often refer it is called it as value function. So we I introduced this value function in very first video of our RL. So whatever reward we are trying to get, we are trying to maximize those reward with time. And this is nothing but we are calling it as value function. So the optimization of our algorithm or our action can be over a finite horizon. Means you can take a fixed number of steps to get the optimized number of rewards, or it could be an infinite horizon. Means it could be a continuous process. So it depends on the problem to problem. So this is the basic concept of your Markov decision process. So as I said already that it is a mathematical approach for mapping a solution in reinforcement learning, which is also called as a Markov decision process. So as you can see in this diagram, we have a certain parameters when we are talking about Markov decision process. So we have a set of actions and we have some set of states. So there is an agent which is going to take some set of action to change the state from current state to the next state or from the start state to the end state. So we have certain set of actions and certain set of states. And whenever agent is changing the state, agent is performing some action. So there is a possibility of changing the state. So whenever we are changing the state, we are trying to get the maximum reward, and the policy or what we can say, the action which we are performing to get the maximum reward is nothing but we are calling it as policy. And finally, whatever rewards we are getting, those are called values. So I hope it is clear to you what are the different parameters we are using in the reinforcement learning. So your agent is trying to explore the environment in such a way that so that he can get the maximum reward, and he's trying to find the best policy to maximize the reward through his action. So this is the Markov decision process. So we'll take a simple example to better understanding of Markov decision process. So I hope everyone knows there is a graph problem which is called shortest path problem. So we have a graph here and we are trying to find the shortest path between A to B. And whenever I'm trying to find the shortest path, my main agenda is I should get the maximum reward. Okay, so I'm trying to find the shortest path with maximum reward. So you can see here we are trying to relate this to the previous diagram. So we have some set of states. My states are A, B, C, D. These are the states. And when you are moving from one state to other state, that is called action. So if you are moving from A to B, so this is one action. If you are moving from A to C, this is another action. So these we have some set of actions, and the values which are written corresponding to every edge, that is called the reward. So if you move from node A to C, you will get the reward 50. If you are moving from node C to D, you will get the reward of 50. So these are nothing but the rewards. And next is policy. Policy is nothing but the path which you are choosing to reach to the destination with maximum reward, that is called policy. So you can see here I can go from A B D. So if I'm using A B D here, if I'm choosing the path A B D, so what is happening here when I'm choosing the path A B D? One second. So when I'm choosing the path A B D, my reward will be 30 plus 10, 40. I reach to D, but reward will be 40. When I'm choosing the path A to D, you can see here I'll get the negative reward. So I should not choose this. When I'm choosing a path from A, C, D, so I have a maximum reward ID 15 plus 50, which is 65, which is maximum. So our main agenda is choosing a policy so that I can get the maximum reward and I should reach to the destination with the maximum reward. So my policy for getting the maximum reward is nothing but A, C, D. If I choose this particular path, I will get the maximum reward. So this is nothing but your Markov decision process, which we are using in a shortest path algorithm. So this is one of the example. Now we'll discuss more in detail about every step. So your Markov decision process is consisting of some set of possible world, which is nothing but a different state. As we have seen earlier, it consists of consisting of set of models, set of possible actions A, and real world reward function, which is R of S of A, and policy solution to Markov decision process. Okay, so you can see here, we'll discuss this in detail that what we are going to do here. So you can see here what is state actually. State is nothing but we have a set of tokens that represent every state that agent can be in. So if you are in the beginning, so if you are moving toward left or right, so you are changing your state. So to reach to the final destination, you are changing your state. So state is nothing but it's a set of tokens that represent every state that agent can enter into it. So this is nothing but a state. So when we are talking about the model, model is nothing but model is nothing but it's a transition model which gives an action effect in a state. So when we are saying I'm in a state S, okay, currently I'm in state S and I'm performing a action A, and whenever I'm performing action A, I reach to the state S dash. So it's defined a transition from state S to S dash using an action A. Okay, so this is your transition model. So you are traversing your transition from state S to state S dash using an action A. So this is my transition. So whenever we are talking about stochastic action, or we can say the noise of non-deterministic action, where We don't have a surety that will reach to the which particular state. So there is no particular surety, or we can say the results are not deterministic. It could be non-deterministic. In that case, we are using the probability function. So we are saying there is a probability that when I am currently in state S, and if I take action A, there is a possibility that I can reach to the state S dash. So this is nothing but it's defining the probability of reaching a state S dash if I'm taking action A. So this is nothing but when I'm having non-deterministic action. So whenever we are talking about Markov decision process, Markov decision property says that the effect of an action taken in a state depends only on that state and not on the prior history. So whenever we are talking about Markov decision process, we should always remember that the action which we are taken in a particular state, it depends only on that state. Not we are not using the previous knowledge or previous knowledge of our action. We are just taking an action from one state to another state. We are not using the previous knowledge of our action. So this is the property of Markov decision process. Okay, now what is action? So we discussed many times what is action. Action is nothing but it defines a set of actions that can be taken to be go into a particular state. Suppose currently I am in a state S and I want to go to state S. I can go like this, I can go like this, I can go like this. So whatever way I'm choosing, so that is nothing but it is an action. So to reach from one state to another state, we have to take multiple actions. So action is nothing but set of all possible actions, and I have to define the action. So I'll define set of all possible actions by using A of S. Okay. Now, what is reward? So, reward is nothing but it's a real value reward function. We discussed already what is reward. Whenever you are performing a certain action and you are reaching to the next state, then you will get some numerical reward, which is nothing but a reward function. And that will be defined by R of S, which indicates the reward for simply being in the state S. So, if I'm saying R S of A, which indicates that the rewards for being in a state S and taking action A, I'm getting a reward R. So it's representing that R, I'm getting reward for being in a state A, choosing an action A and ending with the state S dash, I'm getting a reward R. So I'm moving from state S to S dash using an action A. So there is a possibility I will get the reward R. So this is nothing but a reward function for me. Understand? So what is the reward function for us? So this is my reward function. Changing state S to S dash using action A. I am going to get some of the reward. It could be any numeric value. So this is the reward. Clear? Now what is policy? Policy is nothing but the way which you are choosing from moving from one place state to another state. So you are in state S and you are going to state S dash. So if you'll go like this, you can go like this, you can go like this. So if I'm going like this, I'm getting a reward 1. Then if I'm going like this, I'm getting reward 1. And if I'm going like this, I'm getting reward 12. So the best policy, the best action which I'm choosing, which will increase my maximum reward or a total reward, that will become a policy. So what is policy? If I'm reaching from state S to S dash and if I'm getting the maximum reward, that particular path for those set of action will now become a policy for me because I'm getting the maximum reward with those set of actions. So in future, it will work as a policy for me. So whenever I'm playing the same game or I'm in the same frame, if I'm using that particular policy, so there is a possibility I will get the maximum rewards. Understand what is policy? So policy is a solution to Markov decision process. A policy is mapping from S to A. So S is my state and I'm performing action A. It indicates that A to be taken while in a state S. We can take action A in a particular state S. Now, to better understanding of this, we can take one simple example here. You can see here there's a grid of size 4 cross 6. So we have a certain grid which is size 4 cross 3. You can see here. So now what we are trying to do, there is an agent left in the grid 1. So this is the agent, there is an agent who is living here. So there is an agent who is in the grid. So in this particular example, we have a grid of 3 cross 4 and our grid is starting from 1, 1. So my agent is here currently. Now our purpose in this particular example is that the agent is to wander around the grid and finally reach to the blue diamond. Finally, the agent has to reach to the blue diamond, which is available in grid number 4, 3. So this is my grid number 4, 3. So this is grid number 1, 1. Okay, 1, 2, 1, 3, 1, 8. There are circumstances. Agent should avoid this fire. So there is a fire here. So if agent is going to choose this particular path, there is a possibility he will enter into the fire and he will get the punishment. So agent has to choose this and has to avoid this particular fire which is available in grid number 4, 2. And you can see here in the grid number 2, 2 also there is a blockage. There is a block in the grid number 2, 2. So agent cannot enter into this side also. Now what are the possibility that agent can move? And agent can move in the direction. So there is it's given that agent can move up, down, left as well as right. So agent can move in any direction, left, right, up and down. But if agent want to get the maximum reward, agent has to remember always that it should not enter into the fire, and agent cannot move this particular place because if it enter into this particular place, there is a blockage. So agent has to choose a setting policy so that agent can reach to the final destination where he's going to get the reward of 1, and agent has to choose a setting policy so that it will get the reward 1, so that particular set of action what agent is taking from moving from one grid to other grid, those set of action will behave as a policy for the next time. So I hope it is clear what exactly the policy is. So same thing is explained here. So I hope it is clear to you. Okay, thank you. Good morning, students. In today's class, we are going to discuss about action selection. So as in the previous classes, we discussed what exactly the action is. We know that a particular agent will be in the environment and he'll try to change his state, try to change his state from one state to another state. Suppose a particular agent is in beginning state and now he want to move to the destination state. So he will perform some actions to move from one state to another state. Now the question is how he should perform the action or how can he even choose the action. So action selection in reinforcement learning refers to the process of choosing an action for an agent to take based on its current policy or its learned values. Action selection will be always based on the policy what agent have taken currently or whatever the previous feedback he has taken or whatever previous learning was there in the for the agent. So when he is this particular state in an environment, the agent need to decide which action to select to maximize its expected future rewards. So suppose a particular agent is in a state S and now he want to move to state S dash and then he has to go to S double dash. Now the question is how he can move from state S to S dash. So there is a possibility that he can use his previous experiences or he can choose the current situation wherever he is getting the maximum reward. He can choose that particular action and he can move from one place to another place. So there are different way of choosing the action selection. So in reinforcement learning, depending on which particular algorithm we are using for action selection, so there are few common techniques are available. We'll discuss one by one. First is greedy action selection. So with the name you can understand, greedy action selection is approach where the agent select the action with the highest estimated value. Wherever agent is getting highest Q value, that particular action is selected by the agent. So that's why we are calling it as greedy action selection. So suppose I am in state S and I want to move in state S dash. I can go like this or I can go like this also. So suppose if I'm going like this, I'm getting a 50 rewards, and if I'm going like this, I'm getting 100 reward. So wherever I'm getting the highest estimated value or a Q value, then in that particular direction we will move. So it choose the action that it believes will lead to the highest immediate reward. So it's not bothered about the next state, it will always lead to the particular state where he is getting the highest immediate reward or long term cumulative rewards. The greedy action selection exploits the current knowledge of the agent. So in the greedy selection approach, if you remember, we have discussed exploration and exploitation. So in the case of greedy action selection, the agent is going to use exploitation rather than using exploration. So whatever the next state will be there with the highest reward without exploring the whole environment, it will choose that particular state as a next state. So that particular action it's going to select. So this in this way greedy action selection method works. Now the next is epsilon greedy action selection. So here in the greedy action selection, we have added one extra terminology with epsilon greedy action selection. So this particular strategy will combine both exploration and exploitation. So if you remember, we discussed just now in greedy selection, we are using exploitation. Okay, we are using exploitation, but in the case of epsilon greedy action selection, we are using exploration as well as exploitation both. We are combining both the method and it will become epsilon greedy action selection. So here agent is going to select the greedy action with the probability of 1 minus epsilon. So whatever action will be selected by the agent, it will be selected with the probability of 1 minus epsilon, and where epsilon is nothing but the exploration rate, in what rate we are trying to explore the environment, and it explore all the random action with the probability of epsilon. So it's going to explore whatever the best possible way to reach from one place to another place. It is going to explore each and every way with the probability of epsilon, and it is going agent is going to select the greedy action with the probability of 1 minus epsilon. So this particular method will allow the agent to balance between exploiting the current knowledge as well as exploring the new action, because it's a combination of both. So we are trying to combine here both exploitation and exploration both. So using exploitation, I am using the current knowledge, which is my greedy action. So I am going to choose the state where I am getting the highest reward, and using the exploration, I am trying to explore the whole environment to get the maximum reward. So this is a combination of both. Clear? Now next is softmax action selection. So we discussed softmax in earlier units also. We know that softmax will work on the probability distribution. Same here also, softmax will work in the same way. So in the softmax action selection method, it assigns the probability to each action based on their estimated value. So for every action will assign the probability based on their estimated value. So if you remember, in the case of softmax classifier, we have done the same thing. We were getting some values, and we are converting those value using the softmax function in the probability. So what is the probability of having performing that particular action to get the maximum reward? So what we are doing, whatever values result we are getting, we are using a softmax selection method and assigning the probability of each action based on their estimated value. So what it will do, it will convert the action value into a probability distribution using the softmax function. So it uses the softmax function and it will convert into the probability distribution. So the action which is having the highest estimated value have higher probability of being selected. So whatever action will give me the highest estimated value, there is a possibility or there is a probability that particular action will be selected first. But the agent still has a chance to explore the suboptimal action. So still we have option that agent still want to explore, rather than choosing the next state with the higher probability, agent may still having option of exploring the suboptimal action. That facility is available in softmax action selection. Clear? Now the last is upper confidence bound action selection. So this is often used in bandit queuing problems, which are simplified version of reinforcement learning. So this is specifically designed for bandit problems where we can use upper confidence bound for action selection. So this upper bound confidence selection is an assign an exploration bonus to actions based on their uncertainty or lack of exploration. So UCB will work on the case of concept of exploration, and here we are trying to assign exploration bonus to every action based on their uncertainty or lack of exploration. So it provides me a balance between exploration as well as in the exploitation by considering both the estimated value of an action and the confidence interval. So we are considering both here the estimated value as well as the confidence interval. So in that way we are using this particular method. So this is your upper confidence bound action selection. So this is all about the action selection method. Thank you. Good morning, students. In today's class, we are going to discuss about Q learning. So it's a very important concept of reinforcement learning. So we will discuss how the Q learning works and what is the use of Q learning. Okay, so as we all know, that reinforcement learning is paradigm of learning process in which learning agent learns over time and behave optimally in certain environment by interacting continuously in the environment. So learning in the beginning, the reinforcement agent don't have any experience, you don't know anything about the environment. As we discussed in the previous session also, if I drop you in a particular island, you will learn with your own mistake. You will learn through the environment. You don't have any knowledge how to behave in an island. So the RL agent will also behave in the same way. RL agent will learn with the hit and trial method. So in that course, agent is learned during the experience of various situations in what particular environment he is working. So these particular things are called states. So when you are moving from one place to another place, you are changing your state. So these are called the state. And whenever However, the agent being in that state may choose from a set of allowable action which may fetch different rewards. So suppose currently you are in a state S and you are moving to state S dash. So there is a possibility that you will get a reward of 50, but at the place of choosing state S to S double dash, maybe there is a possibility you are getting the reward 2. So as per your action, what you have taken in that particular environment, your reward will be decided. So you will get the different reward or penalty as per your actions. So over the time, agent is going to learn that how I can maximize my rewards. How can I get the optimized solution so that the award should be maximum, or how I should choose one state to another state so that the reward should be maximum. So here Q learning works. So Q learning is a basic form of reinforcement learning that use the concept of Q values to iteratively improve the behavior of learning agent. So we are using a concept of Q value here, and we are trying to improve the behavior or learning of the agent. So this is all about the Q learning. So you can see here the diagram where we are talking about the Q learning. We have an apple. Okay, so this is my input. We don't know what exactly it is. So the response, what agent is giving, agent is saying it is a mango. So obviously, if agent is saying mango and it is an apple, so it will be a punishment. Agent will get a punishment. He will get a feedback that your action is wrong. Okay, and it will learn. It will note that what if I say this apple as a mango, it is a wrong decision. So learner will learn that this is at least not a mango. Okay, in that way he will keep on exploring, and finally agent will understand that this is an apple, and now onwards agent will always respond that this is an apple. So agent have done learning with their own mistakes. So model have learned optimally after performing some certain actions. Model have learned that this is an apple. So Q learning will behave in the same way, where we are trying to make a reinforcement learning agent to learn with the mistakes and try to get the optimal solution so that we can maximize the rewards. Okay, so now we'll discuss with an example. Suppose consider these are the rooms. Okay, these are the rooms, and we are placing an agent in any one of the rooms. So we have room number 0, 1, 2, 3, 4, and 5. Fine. So there are 6 rooms are available in the building, and room is numbered by 0 to 4. So these rooms are numbered. Outside the building, there can be one big room. So this is within the building, and this is outside the building, which we consider as the room number 5. And doors 1 and 4 lead into the building from room number 5. So whatever doors are there, here we have one door, and here also we have one door. So with these doors, I can enter into the room which is outside the building, and that room number is 5. So we have this particular scenario here. So what we are saying here, I'll repeat again. We have total 5 rooms inside the building, 0 to 4, and I have another room which is outside the building with room number 5. I have a gate. I have a door which is directly connected to room number 5, which is from room number 1 to room number 5, and the same way from room number 4 to I can go directly to room number 5. So there is no other way of going from room number 2 to 5 directly. So you have to cross 2, 3, 1, and then you can reach to the 5, or you can different way. Now the question is agent. We have an agent. Suppose agent is placing in a particular room. Now the question is agent has to move from one room to another room, or you can take in a scenario agent wants to move from room number 3 to room number 5. So what should be the optimal solution so that agent can go to room number 3 to 5 with highest reward? This could be the way that agent can go, and this could be another way where how agent can go from room number 3 to 5. Now the question is which path or which particular strategy or which particular policy agent has to use so that the reward will be maximum. So this problem we are going to solve with the help of Q learning. Now the same thing we are representing through graph. So this particular scenario we are representing through graph here. So same thing we have represented here. You can see here we have 6 rooms, 0 to 4 and room number 5. So here it's showing the arrows. It means room number 1 is connected to room number 3. You can see here from room number 1 you can go to room number 3, and room number 3 you can go to room number 1. So that's why we kept arrow in both the directions. Same way you can go from room number 2 to 3 and 3 to 2. So we have a connection here. Same way you can go from room number 0 to room number 4. Okay, and the same way you can go from room number 4 to 5 and 5 to 4. Clear? But and same way you have, obviously you can go from room number 5 to 5 also. We have mentioned that scenario also, that we can go from room, we can be in room number 5 also. Okay, so see doors are represented as a link. If I'm saying the doors that are direct. So in the good morning students. So in the last class we discussed about the Q learning concept. Now we have taken one simple example in the last class, where we have seen that we have a room, we have a particular building which is consisting of 5 rooms, and those 5 rooms are available within the building, and the other room was available outside the building, and we were trying to move from one room to another room. So the room which are directly connected to the outside room, which is room number 5, so you are getting the reward 100, otherwise you are getting the reward 0. And the rooms which are not at all having a direct link between each other, so there we get the value -1. So we prepared this R matrix in the previous class. So this is my reward matrix which we have prepared. Now we are trying to solve this particular example with the help of Q learning, and I
Hello world, it's Siraj, and let's see if we can teach an AI car how to drive to the top of a mountain using a super popular strategy called Q-learning. Since video games are considered virtual worlds, we'll want to use reinforcement learning to help our AI learn how to best interact with its environment. That means using time-delayed labels, aka rewards, to help it learn how best to act in the environment through trial and error to complete its objective. If an AI has a model of all the necessary elements of its environment, meaning the states, rewards, transition model, etc., basically everything that makes up a Markov decision process, it can easily then use a planning algorithm to compute a solution to whatever its objective is. So easy a liberal arts major could do it. This is considered model-based learning. An AI will interact in the environment, and from the history of its interactions, the AI will try to approximate the environment's models. Afterwards, given the models it's learned, the AI can use the value iteration or policy iteration algorithms to find an optimal policy. But our agent doesn't necessarily have to try and learn an explicit model for its environment. It can also derive an optimal policy directly from its interactions with the environment without building a model. And this is called model-free learning. Model-free learning involves predicting the value function of a certain policy without having a concrete model of the environment. The simplest way to do this is using the Monte Carlo technique, meaning using repeated random sampling to obtain numerical results. But this only works on episodic tasks where you have
सब्सक्राइब टू नॉलेज गेट बाइट्स चैनल, जहां हम डिस्कस करते हैं कंप्यूटर साइंस रिलेटेड टॉपिक्स स्मॉल वीडियोस में। काम करते हैं ना, हर चीज़ की एक प्रोबेबिलिटी होती है ना। तो फॉर एग्जांपल अगर हमें स्टेट ए से स्टेट बी पे जाना है, तो इस बात की प्रोबेबिलिटी हो सकती है कि क्या रास्ते में कोई एक्सीडेंट हो जाए, ट्रैफिक बहुत ज्यादा मिले। इस बात की भी प्रोबेबिलिटी हो सकती है कि ट्रैफिक बहुत कम मिले, और इस बात की भी स्पेसिफिक प्रोबेबिलिटी हो सकती है कि ट्रैफिक मीडियम मिले। तो कोई भी जब हम काम करते हैं, है ना, तो वी कैन नॉट बी डिटरमिनिस्टिक इन रियल लाइफ बिकॉज़ एवरीथिंग इज फजी। मार्कऑफ डिसीजन प्रोसेस, ये जो हमारा क्यू लर्निंग है, वो इस चीज को एंटिसिपेट करता है, इस चीज को वैल्यू करता है। नाउ आई विल गेट इनटू दैट। सो अ मार्कऑफ डिसीजन प्रोसेस इज अ मैथमेटिकल फ्रेमवर्क यूज्ड टू डिस्क्राइब एन एनवायरनमेंट इन रीइंफोर्समेंट लर्निंग। तो रीइंफोर्समेंट लर्निंग का ये एक एक्सटेंशन है, एक ऐसा एनवायरनमेंट वेयर इट प्रोवाइड्स अ फॉर्मल मॉडल फॉर डिसीजन मेकिंग इन सिचुएशन वेयर आउटकम आर पार्टली रैंडम और पार्टली अंडर द कंट्रोल ऑफ द डिसीजन मेकर और एजेंट। तो ना ये ऐसा है कि 100% रैंडम है, मानो भगवान ही डिसाइड कर रहा है, और ना ही ऐसा है कि सब कुछ हमारे हाथ में है। कुछ चीज हमारे हाथ में है कि हम कौन सा रास्ता चूज करें, बट उस रास्ते में एक्जैक्टली क्या सिचुएशन आए, ट्रैफिक कैसा मिले, कोई और गड़बड़ ना हो जाए, तो हर चीज के होने की कुछ ना कुछ प्रोबेबिलिटी होती है। तो उन दोनों चीजों को वैल्यू करता है मार्कऑफ डिसीजन प्रोसेस, और बहुत इंपॉर्टेंट फ्रेमवर्क है, बहुत जगह यूज होता है। यस, तो क्या क्या कैरेक्टरिस्टिक्स है? फर्स्ट इज मार्कऑफ प्रॉपर्टी। द फ्यूचर स्टेट depends only on the current state and the action, not on the sequence of the events that preceded it. तो पहले क्या हुआ अभी हम उसकी बात नहीं करते। मेरा करंट स्टेट क्या है? लेट मी से मेरा करंट स्टेट क्यू नॉट है। मैं क्या एक्शन परफॉर्म कर रहा हूँ? लेट मी से आई एम परफॉर्मिंग इन एक्शन ए एंड आई एम गोइंग टू स्टेट Q1। तो पहले तो इस चीज पर हम डिपेंडेंट करते हैं, इसीलिए लाइक ऑटोमेटा टीयूसी में हम पढ़ते हैं ना, इट इज काइंड ऑफ अ मेमोरी लेस सिस्टम। तो पहले क्या किया क्या नहीं किया उस बात से कोई फर्क नहीं पड़ता, मैं फिलहाल इस स्टेट पे ध्यान दे रहा हूँ। बट सेकंड इंपॉर्टेंट थिंग इज पॉलिसी। आमतौर पे पाई से रिप्रेजेंट करते हैं स्ट्रेटजी और रूल दैट डिफाइंस एक्शन टू बी टेकन एट ईच स्टेट। तो हर स्टेट पे क्या एक्शन हम लेंगे, और ऑब्वियसली पुरानी अंडरस्टैंडिंग में हमारे साथ रीइंफोर्समेंट लर्निंग वाली, तो जो एक्शन लेंगे उसका क्या रिवॉर्ड मिलेगा, एक्शन लेना चाहिए नहीं लेना चाहिए, बट आगे डिटेल में समझेंगे विद अनसर्टेनिटी आइडिया। तो हर बार वो परफेक्ट चले जरूरी नहीं है, कुछ गड़बड़ भी हो सकती है। ये एक फ्रेमवर्क है जिससे इस चीज को हम टेक्निकली फ्रेम कर सकते हैं, मॉडल कर सकते हैं। मैं एक एक करके पूरी बात आपको समझाता हूं। तो सबसे पहला जो आइडिया है वो है टपल बोल सकते हैं स्टेट। तो कौन कौन सी सारी पॉसिबल स्टेट्स हैं जिसमें हमारा मॉडल हो सकता है, मैं साथ साथ आपको कंपेयर करके दिखा देता हूं। ये ग्रिड गेम इमेजिन करो, तो यहां पर हाउ मेनी स्टेट्स आर देयर? सो आई थिंक 4 into 3 देयर आर 12 डिफरेंट स्टेट्स आर पॉसिबल। तो पहली चीज हमने डिफाइन कर दी। सेकंड इज एक्शन। किसी भी स्टेट पे कौन कौन से एक्शंस आप परफॉर्म कर सकते हो। तो यू कैन इमेजिन जैसे इफ एन स्टेट 5 दो एक्शन हो सकते हैं, आइदर यू गो अप और यू गो डाउन। ऑन द कंट्री आप S2 पे है तो दो एक्शन हो सकता है, आइदर यू गो लेफ्ट और यू गो राइट। अगर आप 7 पे अगेन यू गो अप एंड यू गो राइट। 11 पे है लेफ्ट राइट और अप, है ना। तो क्या एक्शंस हो सकते हैं वो हम डिफाइन करेंगे। देन वी हैव अ ट्रांजिशन फंक्शन एंड टू बी स्पेसिफिक प्रोबेबिलिटी फंक्शन। तो देखो क्या बोल रहा है, P ऑफ S डैश S, A defines the probability of transiting a state S dash from a state S। तो ये कह रहा है अगर आप किसी स्टेट S पे हैं और ट्रांजिटिंग टू अगर आप S पे हैं तो S डैश पे जाने की कोई प्रोबेबिलिटी ये फंक्शन बताएगा अगर आप एक्शन ए परफॉर्म करते हैं। मानो 100% प्रोबेबिलिटी नहीं है, तो हो सकता है लेट मी से फॉर एग्जांपल 0.8 में इसकी वैल्यू करता हूं। तो अगर आप एक्शन ए परफॉर्म कर भी देते हैं तो भी इस बात के 80% चांस है कि आप यहां पर पहुंचे, और हो सकता है कुछ गड़बड़ हो जाए, आप यहां पर ना भी पहुंच पाए। तो हर चीज एक प्रोबेबिलिटी के साथ हम डिफाइन करेंगे। वी हैव अ रिवार्ड फंक्शन so that provide the immediate reward received after the transition from a state S to S dash due to action A। तो एक रिवॉर्ड फंक्शन हम बना लेते हैं कि अगर आपने एक्शन सच में अच्छे से परफॉर्म कर लिया, कुछ गड़बड़ नहीं, तो क्या रिवॉर्ड हम आपको देंगे, जो पुराना रीइंफोर्समेंट लर्निंग का हमारा अंडरस्टैंडिंग चल रहा है। एंड देन वी हैव अ डिस्काउंट फैक्टर represents the difference in importance between the future reward and the present reward। वो आगे जाके हम देखेंगे कि एक डिस्काउंट फैक्टर भी हम लेके चलेंगे कि आप जहां पहुंचे, है ना, वो सिर्फ इसी बात पे डिपेंड नहीं करेगा इससे आगे गोल तक पहुंचने के कितने रास्ते हैं, उससे क्या रिवॉर्ड है। तो जो रिवॉर्ड यहाँ पर आपको ये एक्शन परफॉर्म करने के लिए मिलेगा वो इन रिवॉर्ड्स पे भी इनडायरेक्टली डिपेंडेंट होगा। मतलब फॉर एग्जांपल अगर यहाँ से कहीं जाके गोल स्टेट आपको मिल रहा है तो आपको रिवॉर्ड बेटर मिलना चाहिए, लेकिन अगर गोल स्टेट मिल ही नहीं रहा तो रिवॉर्ड इतना अच्छा नहीं होना चाहिए। आगे जाके आपको समझाऊंगा इस बात का क्या मतलब है ना। तो 5 फैक्टर हमारे पास है और वो पांचों आइडियाज इसके केस में हम यहाँ पे लिख रहे हैं। जैसे अगेन देखिए, इसने माना 80% चांस है कि सब कुछ ठीक हो, मूव ठीक से चले, बट 20% चांस इस बात के भी हो सकते हैं कि हमारा रोबोट, हमारा एजेंट स्लिप कर जाए, जरूरी नहीं है। रिवॉर्ड में फॉर एग्जाम्पल अगर आप गोल पे पहुंचे तो दे कैन बी एन आइडिया कि हम +10 आपको देंगे, और आपने कुछ गड़बड़ घोटाला कर दिया, ट्रैप में पहुंचे तो यूल गेट अ -1। काम ये कैसे करता है, इसको अगर अच्छे से समझना है तो एक आइडिया है हमारे पास क्यू लर्निंग मॉडल, है ना। और क्यू लर्निंग आपको मार्कऑफ डिसीजन प्रोसेस का ही एक एक्सटेंशन है, और न्यूमेरिकली इस बात को समझेंगे तो आपको एकदम क्लैरिटी होगी, एग्जाम में भी डायरेक्ट क्वेश्चन आप इस पे एक्सपेक्ट कर सकते हैं। सो क्यू लर्निंग इज अ मॉडल फ्री रीइंफोर्समेंट लर्निंग एल्गोरिथम यूज्ड टू फाइंड एन ऑप्शनल optimal action selection policy for any given finite Markov decision process model। तो समझना क्या है, किसी भी स्टेट पे क्या एक्शन लेना है, इसका एक फ्रेमवर्क हम डिजाइन कर रहे हैं। मार्कऑफ डिसीजन प्रोसेस इज अगेन हाउ यू मेक द डिसीजन, और क्यू लर्निंग उसी के थोड़ा सा एक्सटेंशन है जहां पे हम न्यूमेरिकली इसको सॉल्व करते हैं। एक और एल्गोरिथम यहाँ पर बीच में आता है नोन एज बेलमैन फोर्ड एल्गोरिथम, बट आई एम नॉट कंसीडरिंग इट बिकॉज उसका एक्सटेंशन हमारा क्यू लर्निंग ही है जो सिलेबस में मेंशन है, तो उस पर डिटेल में बात करेंगे। आई थिंक दैट विल बी मोर बेनिफिशियल। तो एक वैल्यू बेस्ड मॉडल है, ऑब्वियसली फोकस करेगा ऑप्टिमल सॉल्यूशन जनरेट करने पे। कैसे काम करेगा मैं एक एक करके आपको समझाता हूँ। एंड दिस इज द एग्जैक्ट इक्वेशन विच वर्क्स। अब ये देखने में थोड़ी खतरनाक आपको लग रही है, बट कैसे काम होगा, क्या होगा, एक एग्जांपल लेके पूरी बात समझाता हूँ। एंड आई कीप रेफरिंग दिस स्लाइड वन बाय वन। तो क्या कह रहा है, इनिशियलाइज कैसे कर रहे हैं। फॉर ईच स्टेट एस एंड एक्शन ए, ये हमारी एंट्री होगी इनिशियलाइज कि अगर स्टेट एस पे हम एक्शन लेंगे तो क्या होगा, और फिलहाल उसे इनिशियलाइज करेंगे 0 से, है ना। एक हमारे पास करंट स्टेट होगी, जितने पॉसिबल एक्शंस है वो होंगे, जहां हम जाएंगे दैट विल बी एस डैश, और ये हमारे पास एक काइंड ऑफ इटरेटिव आइडिया है जिससे हम ये पता लगाएंगे कि हमारा रिवॉर्ड वैल्यू क्या होना चाहिए। मैं क्या बोलना चाह रहा हूँ एक एक करके आपको समझाता हूँ। एक छोटा सा केस स्टडी लेते हैं इन क्यू लर्निंग एल्गोरिथम, दैट इज अ वेरी पॉपुलर आइडिया। सो लुक एट दिस, ये हमारे पास किसी हाउस का एक आर्किटेक्चरल डिजाइन है, जहां पर आप देख रहे हैं कि देयर आर मल्टीपल रूम नंबर 0 1 2 3 एंड 4, और डोर्स आपको ओपनिंग बता रहा है कि इधर से किधर जा सकते हैं। नाउ द गोल इज, या आइडिया इज फॉर एग्जांपल, हमें घर के बाहर जाना है, हमें जाना है स्टेट नंबर 5 पे, है ना। ये भी देखिए 4 से जब आप ओपन करेंगे तो भी बाहर का पूरा पार्ट एक है, तो आप इसको मान सकते हैं 5 पे आ गए। इस पूरे आइडिया को यहां पर आप नोटिस करिए हमने क्या किया, हमने इसको ग्राफ में कन्वर्ट कर लिया, जहां पर यू कैन मैच दिस कि 2 से 3 पे ट्रांजिशन हो सकता है, हाँ हो सकता है, बस एक ही पॉसिबिलिटी। 3 से देखिए, 3 से 1 पे, और 4 से सिर्फ 4 से आप बाहर 5 तो ओपन है ना, तो 1 से भी 5 पे जा सकते हैं, 4 से भी 5 पे जा सकते हैं, 1 से 4 से दोनों से 5 पे जा सकते हैं, और ऑब्वियसली हमारा गोल स्टेट है 5। ये मॉडल आपको समझ आ गया ना। लुक एट दिस डायग्राम, जब हमने इनिशिएट किया तो मान के चलो कि जैसे ही आप गोल पे पहुंचेंगे आपको रिवॉर्ड मिलेगा 100। अब 3 सिर्फ ट्रांजिशन ऐसे हैं, एक तो लॉजिकली ऑब्वियसली कि आप 1 से 5 पे गए देन यू गेट 100, आप 4 से 5 पे गए उस वाले रूम से गए देन आल्सो गेट 100, और एक लॉजिक हो सकता है सेल्फ लूप का कि 5 पे थे, 5 से 5 पे अगेन यू विल गेट 100। बाकी सबको नोटिस करिए, फिलहाल हमने इनिशियलाइज किया 0 से, ये स्टार्टिंग है, बट धीरे-धीरे हमें समझ आना चाहिए हर स्टेज पे जैसे जैसे रीइंफोर्समेंट लर्निंग काम करेगा, क्यू एल्गोरिथम काम करेगा, क्यू लर्निंग काम करेगी, हमें समझ आना चाहिए कि यार इस मूव की क्या वैल्यू है। 0 तो नहीं हो सकती ना, 100 भी हो सकती, कुछ बीच में होनी चाहिए, है ना। वो कैसे फिगर आउट करते हैं, इटरेटिवली रिकर्सिवली धीरे-धीरे हम सीखते हैं कैसे सीखता है, 1 बाय 1। तो सबसे पहले आप देखिए एक रिवॉर्ड मैट्रिक्स आर यहां पर हमने इनिशियलाइज कर ली, एंड इट्स एन क्रॉस एन मैट्रिक्स, तो 0 से लेके 5 तक सारे रूम्स, 0 से लेके 5 तक सारे रूम, और सारे पॉसिबल मूव हम यहां पे दिखा रहे हैं। कैसे दिखा रहे हैं नोटिस करिए, जैसे यहां देखिए फर्स्ट रो में 0 रो में सिर्फ एक जगह लिखा हुआ है 0, यानी कि 0 से आप सिर्फ 4 पे जा सकते हैं, और फिलहाल तो क्योंकि इनिशियलाइज 0 से किया यू गेट रिवॉर्ड 0, और -1 लिखने का मतलब है कि मूव कर ही नहीं सकते, देयर इज नो पॉसिबल मूव। और कोई देख लो 3 पे देख लो, तो 3 पे यू कैन सी 1 2 एंड 3, तीन जगह 0 लिखा हुआ है, तो 3 से आप 1 पे आ सकते हैं, यस 4 पे आ सकते हैं, यस 2 पे आ सकते हैं, फिलहाल सब 0 है, दो इट्स नॉट अ गुड थिंग, धीरे-धीरे हम इसे इंप्रूव करेंगे, एंड लाइक 1 से 5 पे जा सकते हैं, तो यहां पे जरूर हम इसको 100 लिख रहे हैं, ये एक आइडिया है। यस, अब एक इनिशियलाइज मैट्रिक्स क्यों, जैसे हमने समझा था एल्गोरिथम में, स्टार्टिंग में बोला था, मैं रेफर करके आपको बताता रहूंगा। तो इनिशियलाइज हम किससे करते हैं, 0 से करते हैं। तो ये एक मैट्रिक्स देखिए हमने क्यू बनाया, उसको इनिशियलाइज कर लिया 0 से। एक लर्निंग रेट हमारा होगा यहाँ पर, तो लेट मी इनिशिएट दिस वैल्यू विद लाइक 0.8, और हमें अलग अलग एपिसोड ट्राई करने पड़े, यहाँ बोलते हैं एपिसोड। तो फिलहाल 2 मिनट के लिए इमेजिन करते हैं कि हम रूम नंबर 1 में है। कौन से रूम में, 1 में। अब आप मुझे बताओगे 1 पे कौन कौन से पॉसिबल मूव्स हो सकते हैं। तो इफ यू आर इन रूम नंबर 1, आइदर यू कैन गो टू 3 और यू कैन गो टू 5, दो ही मूव हो सकते हैं। तो नाउ मैं एक एक बात स्टेप लिखता हूँ और आपको समझाता हूँ, है ना। तो अगर हम 1 पे हैं तो जैसे मैं आपको समझा रहा हूँ विद द हेल्प ऑफ डायग्राम, दो ही पॉसिबल मूव है, 3 हो सकता है या 5 हो सकता है। अब हमें सोचना पड़ेगा हमने क्या मूव लिया, रैंडम सिलेक्शन है, फिलहाल कोई वैल्यू नहीं है। लेट मी इमेजिन एन एपिसोड कि हम 1 से 5 पे गए, है ना। तो अगर हमने एक्शन लिया 1 से 5 का, तो बोलो हमारा नेक्स्ट स्टेट या करंट स्टेट अब क्या हो जाएगा, 5 हो जाएगा। और अब देखिए ये Q1,5 पे क्या Q1,5 की वैल्यू हम कैसे कैलकुलेट करेंगे, बेसिकली इसको इंप्रूव कैसे करेंगे। तो लुक एट दिस Q1,5 एंड दिस इज एन एल्गोरिथम। तो एल्गोरिथम कैसे काम कर रहा है, सबसे पहले कौन से स्टेट पे क्या एक्शन लिया। तो हम 1 स्टेट पे थे और हम एक्शन ले रहे हैं 1 से कहाँ जाने का, 5 पे जाने का। लर्निंग रेट हमारा 0.8 है, तो दिस गामा को लर्निंग रेट कहते हैं। लेट मी इनिशियलाइज विद 0.8, और फिर क्या कह रहे हैं, जिस भी नेक्स्ट स्टेट पे आप गए उससे कौन कौन से पॉसिबल एक्शन हो सकते हैं उसका हमें मैक्स देखना है। तो अगर आप 5 पे गए तो 5 से कौन कौन से एक्शन पॉसिबल है, 3 पॉसिबल है, या तो वापस 1 पे आएंगे, या तो आप सेल्फ लूप लेंगे, या तो 4 पे जाएंगे। या तो आप 1 पे आएंगे, या तो सेल्फ लूप लेंगे, या तो 4 पे जाएंगे। और क्यू मैट्रिक्स देख के आप मुझे बता सकते हो 5,1 5,4 5,5, बताओ मैक्सिमम वैल्यू क्या है। 5,1 5,4 एंड 5,5। सर फिलहाल तो सब 0 है, तो अगर ये सब 0 है तो इसमें से मैक्स भी पिक करूंगा तो 0 ही मिलेगा, एंड 0 into 8 अगेन आई एम गोइंग टू गेट 0। बट व्हाट इज R1,5, तो R1,5 इज 100 बिकॉज ये तो बेस्ट मूव था, है ना। तो अब ये जो Q1,5 की जो वैल्यू है ये भी हमारी क्या हो गई, 100 हो गई। एंड यू सी Q1,5 पे जहां अभी हमने क्या लिखा हुआ था 0, नाउ लेट मी चेंज दिस वैल्यू टू 100। बताइए इतनी बात ऑब्जर्व कर पा रहे हैं क्या, है ना। तो इसको बोलते हैं एपिसोड। तो ये एक एपिसोड था जिससे हमने समझा कि यार 1 से मल्टीपल मूव्स थे, बट 1 से 5 वाला जो मूव है, 1 से 5 वाला एक अच्छा मूव है, और ये मूव लेने से हमें टोटल प्रॉफिट मिल रहा है या रिवॉर्ड मिल रहा है 100, तो हमने इसको ऐसे सेट कर दिया। अब व्हाट यू कैन डू, यू कैन कंसीडर सम अदर स्टेट। फॉर एग्जांपल धीरे धीरे मशीन लर्न करता है, तो इस बार मान लेते हैं 2 मिनट के लिए कि हमारा इनिशियल स्टेट 3 है, हम यहाँ पर है। अब 3 तो देखिए बहुत शानदार है, 3 से आप 1 पे भी जा सकते हैं, 4 पे भी जा सकते हैं, एंड 2 पे भी आ सकते हैं, है ना। तो जैसे मैंने यहाँ पे लिखा भी है, देखिए यू कैन गो टू 1 और 2 और 4। मान लीजिए 2 मिनट के लिए फिलहाल हम चूज करते हैं कि हमको 1 पे जाना है ना। अब फिर वो ध्यान रखिएगा, तो 3 से 1 पे हमें जाना है, देखिए भी जा सकते हैं, एंड 2 3 तो देखिए बहुत शानदार है, 3 से आप 1 पे भी जा सकते हैं, 4 पे भी जा सकते हैं, एंड 2 पे भी आ सकते हैं, है ना। तो जैसे मैंने यहाँ पे लिखा भी है, देखिए यू कैन गो टू 1 और 2 और 4। मान लीजिए 2 मिनट के लिए फिलहाल हम चूज करते हैं कि हमको 1 पे जाना है ना। अब फिर वो ध्यान रखिएगा, तो 3 से 1 पे हमें जाना है, R3, 1। जब 1 पे जाएंगे तो 1 से क्या क्या पॉसिबिलिटी, सर 1 से 2 ही पॉसिबिलिटी होगी, या तो बैक टू 3 आएंगे या तो 5 जाएंगे, एंड यू सी 1 3 एंड 1 5। अब Q1 3 और 1 5 पे बताइए क्या लिखा है, Q1 3 और 1 5। तो एक जगह 0 एक जगह 100 है, ऑब्वियसली हमें मैक्स चूज करना है, तो यहां से हमें मिलेगा 100 इंटू 0.8 यू गेट 80, एंड व्हाट इज R3, 1, R3, 1 यू गेट अ 0। लेकिन 0 प्लस 80 करेंगे तो भी क्या मिलेगा, हमें मिलेगा 80। तो 3, 1 की नई अपडेटेड वैल्यू हो गई 8080, और यहां मैं चेंज कर दूं 3, 1। सो 3, 1 पे दे यू सी नाउ वी गेट एन 8080। तो अब देखिए पहली बार ऐसा हुआ कि 3 से 1 की जो मूव है उसका रिवॉर्ड 0 नहीं है सर, उसको कुछ इंप्रूव्ड आइडिया है, नाउ दैट इज 80। आपको समझ आ रहा है कि रियल आइडिया क्या है। अब ये काम कब तक करेंगे, तो ऑब्वियसली ये काम अलग अलग स्टेट में अलग अलग पॉसिबिलिटी के साथ आपको करते जाना है, और आप इटरेटिवली बार बार ट्राई कर सकते हैं जब तक ये वैल्यू मॉडिफाई होना बंद ना हो जाए। जब आप कुछ समय तक ये पूरा आइडिया रिपीट करेंगे तो लुक एट दिस, ये क्यू मैट्रिक्स कुछ यहाँ पे जाके स्टेबलाइज होगी। हाँ, जब मॉडल की काफी ज्यादा लंबे टाइम तक हमने लर्निंग कर ली, नाउ यू अंडरस्टैंड कि क्या शानदार आइडिया है। अब अगर आप 2 पे हैं, किसी भी स्टेट पे सोच सकते हैं, आप 2 पे हैं, आपको डेस्टिनेशन पे जाना है, तो 2 पे तो खैर एक ही पॉसिबल मूव है, बट दे यू सी यू गेट अ रिवॉर्ड 64। मान लीजिए 0 से 100 गेज में 64 इज गुड रिवॉर्ड। अब आप 3 पे, मॉडल सोच रहा है कहाँ जाए, 2 ऑप्शन है, यू कैन गो दिस वे और दिस वे, एंड यू कैन गो बैक। अब मजे की बात क्या है, इसका रिवॉर्ड 80 है, इसका रिवॉर्ड 80 है, इसका 51 है, क्या चूज करोगे, फिर 80 वाला चूज करोगे, तो मे बी यू गो अप। यहाँ पर 2 मूव है, वापस आओगे तो 64 मिलेगा, आगे जाओगे तो 80 मिलेगा, और सॉरी आगे जाओगे तो 100 मिलेगा, क्या चूज करोगे, 100 करोगे। सो यूजिंग दिस आइडिया नाउ यू कैन सी मॉडल ट्रेन हो जाएगा और बहुत शानदार तरीके से अपने फाइनल डेस्टिनेशन पे पहुंच सकता है। तो ये एक पूरा आइडिया था क्यू लर्निंग का, रीइंफोर्समेंट का ये एक एक्सटेंशन था, और विद कंसीडरिंग द प्रोबेबिलिटी कि हर बार हम परफेक्ट काम नहीं करेंगे, लर्निंग का रेट हमने 0.8 रखा है, 0.2 गड़बड़ भी हो सकता है ना। तो आई होप इस एग्जाम्पल से फॉर्मूला कैसे यूज करना है, वैल्यू पे कैसे काम करना है, पूरी इस केस स्टडी आपको समझ आ गई होगी। दीज आर द स्टेप्स जो हमने रिपीट किए। करंट स्टेट देखो, फिर पॉलिसी चूज करो, नेक्स्ट स्टेट पे जाओ, अपडेट करो, एंड देन यू कीप रिपीटिंग दिस प्रोसेस जब तक कि हमें ऑप्टिमाइज वैल्यू नहीं मिल जाए या कन्वर्जेंस होना बंद ना हो जाए। नाउ एक लास्ट पॉइंट, एक्सटेंशन ऑफ क्यू लर्निंग इज कॉल्ड डीप क्यू लर्निंग। ये क्या है, न्यूरल नेटवर्क वाला आइडिया, आर्टिफिशियल न्यूरल नेटवर्क तो हम पहले पढ़ चुके हैं, उसकी पूरी क्या अंडरस्टैंडिंग और कैसे वहां चीजें लर्न करती है, कैसे मशीन लर्निंग होती है। कभी कभी क्या ऐसा हो सकता है कि क्यू लर्निंग जहां पर हम अप्लाई कर रहे हैं वो इतना कॉम्प्लेक्स फ्रेमवर्क है जिसको पूरी तरह से इतने सारे पैरामीटर से फॉर्मूला में पिरोना, समझना, समझाना बहुत टफ हो सकता है। हाँ पॉसिबल है, वहां पर कैन वी मर्ज द आइडिया ऑफ न्यूरल नेटवर्क्स एंड दैट्स क्यू लर्निंग टुगेदर किया जा सकता है, उसी का नाम है डीप क्यू लर्निंग। सो व्हाट इज दिस डीप क्यू लर्निंग, इन शॉर्ट DQL इज एन एक्सटेंशन ऑफ क्यू लर्निंग, uses deep neural network to approximate the Q value। डायरेक्ट फॉर्मूले से कैलकुलेट ना करके अंदाजा लगाते हैं न्यूरल नेटवर्क की मदद से। दिस मेथड इज पार्शियली यूजफुल इन हैंडलिंग हाई डायमेंशनल स्टेट स्पेस वेयर द ट्रेडिशनल क्यू लर्निंग बिकम्स इम्प्रैक्टिकल ड्यू टू एक्सपोनेंशियल ग्रोथ इन द नंबर ऑफ स्टेट एक्शन। तो इतना कॉम्प्लेक्स हो सकता है कि एग्जैक्ट कैलकुलेशन करना बहुत टफ होगा, तो बेटर है कि हम न्यूरल नेटवर्क का सहारा यहां पर ले। आई नॉट गोइंग टू वेरी डीप, एक बेसिक आइडिया, अगर हम सिर्फ क्यू लर्निंग यूज करते हैं, आपने देखा स्टेट है, एक्शन है, पूरा टेबल हम बनाते हैं, उसको इटरेटिवली इंप्रूव करते जाते हैं, अंडरस्टैंड एक्शन लेना चाहिए। अगर टेबल फार्मूला के बजाय हम न्यूरल नेटवर्क यूज करने लगे, बस दिस इज द कांसेप्ट। सो विद द हेल्प ऑफ दिस न्यूरल नेटवर्क, ऑब्वियसली हमें नहीं पता होगा एग्जैक्ट वैल्यू कैसे आ रही है, बट वो ट्रेड करते रहेंगे, पूरा हमने सीखा बैक प्रोपगेशन एंड ऑल, उसको यूज करके न्यूरल नेटवर्क अपनी लर्निंग इंप्रूव करेगा, एंड देन यू गेट टू नो कि क्या एक्शन परफॉर्म करना है ना। अगर कंक्लूड करो इस बात को, क्या क्या बेनिफिट्स है, हाई डायमेंशनल स्टेट स्पेस अच्छे से काम करेगा, जनरलाइज अक्रॉस सिमिलर स्टेट्स रिड्यूसिंग द नीड ऑफ एग्जॉस्टिव स्टेट पेयर ऑफ एन्यूमरेशन, जैसे हमने देखा बार बार सारी वैल्यू पे काम करना है, चेक करना है, वो करने की जरूरत नहीं पड़ेगी। एंड एक्सपीरियंस रिप्ले इंप्रूव सिंपली एफिशिएंसी एंड स्टेबिलिटी, जैसे जैसे आप इसको भी इंप्रूव करते जाएंगे न्यूरल नेटवर्क की वही कहानी, जितना ज्यादा चलाएंगे काम करेंगे कहानियां इंप्रूव होती जाएगी। लेकिन क्या चैलेंजेस हो सकते हैं? ट्रेनिंग ऑब्वियसली समटाइम कैन बी अनस्टेबल ड्यू टू नॉन स्टेशनरी टारगेट वैल्यूज, देयर कैन बी कॉम्प्लेक्स एनवायरनमेंट जहां गोली चेंज हो रहा है हमारा, एक एयरक्राफ्ट दूसरे एयरक्राफ्ट का पीछा कर रहा है, उसको हिट करने के लिए, बट वो भी मूव कर रहा है, देन यू हैव टू बार-बार वैल्यूज पे काम करना पड़ेगा, रिक्वायर्स सिग्निफिकेंट कंप्यूटेशनल रिसोर्स। अब न्यूरल नेटवर्क भी अगर आपको रन करना है तो उसकी अपनी कॉस्ट है, कॉम्प्लेक्सिटी है। हाइपर पैरामीटर ट्यूरिंग, तो बहुत सारी चीज आपको सेट करनी पड़ेगी, लर्निंग रेट क्या है, बैच साइज क्या होना चाहिए, न्यूरल नेटवर्क के जो भी आइडिया, तो उसका आपको यहाँ पे ध्यान देना पड़ेगा, है ना। सो दैट इज द बेसिक आइडिया, आगे की बात तो भी करेंगे। सो दिस इज ऑल अबाउट दिस डीप क्यू लर्निंग एल्गोरिथम। सो ये जो हमारा लास्ट यूनिट है बेसिकली, तो 3-4 आइडियाज, रीइंफोर्समेंट लर्निंग कैसे काम किया, उसका जो एक्सटेंशन था मार्कअप डिसीजन प्रोसेस, एक फ्रेमवर्क हमने समझा प्रोबेबिलिटी के साथ, और न्यूमेरिकली उसको समझा हमने क्यू लर्निंग और डीप लर्निंग में। अगला टॉपिक हमारा होगा दिस आइडिया ऑफ जेनेटिक एल्गोरिथम, जो कि अपने आप में शानदार आइडिया है, तो आने वाली वीडियोस में इसके ऊपर काम
Good afternoon, students. Today we are going to discuss machine learning applications as well as reinforcement learning applications. So this is the last topic of our fifth unit. So when we are talking about reinforcement learning, as we know that it is having a wide scope in the various area and various domains. So we discuss one by one that where it's playing a major role in different area. The game, as we all know that most of the kids are involved in the playing the game in their phone. So most of the games which we are playing in our mobile phone or laptop, they are built on the basis of reinforcement learning. So there is a very successful story available for reinforcement learning to build a game. Okay, so RLP can apply in different games like Candy Crush game when people, which is very popular game, and chess, poker, or any video game where agent can learn through mistakes and take the decision and optimize the game with further attempts. Okay, so there reinforcement learning playing a major role. The other major role where RL is playing is in the field of robotics. So as we have seen that during the pandemics, during the COVID pandemics, many robots were there who were giving services to the patient when there are physically it was not allowed to go to the near to the patient. So there our robotics have played a major role. In the same way, robotics are playing a major role in many fields. Suppose I want to clean a 20-floor building. So nowadays we are getting a robot which are able to do such tasks. So in the field of robotics also, RL is playing a great role. So same way here also we're working in the same concept, that is learning from the environment, receiving the reports, and robot is getting the optimal policy for accomplishing the final task. Okay. Now, this RL is also playing in our automatic vehicles also. As we have seen that a lot of development has been happening in the self-driving cars and drones. So those all automatic vehicle which are having which doesn't require any driver to drive, there RL is playing major role, where RL agent is able to navigate agent to make the decision and respond on the traffic conditions also. Okay, and at the same time they are considering that it should have all the safety measurement it should have considered. The another one where RL is playing role is in the resource management. So suppose I'm running with a company and I'm having a multiple resource. Okay, now which resource I have allocated to whom and for how much time period I want to manage all these things, so I can manage through RL again. So we have taken example here. Suppose I have an energy management problem, so I can take an help of RL, which can check the balance of every electricity grid which are available. What is their optimized power consumption on daily basis or hourly basis or weekly basis? Accordingly, I can allocate resources efficiently. So it is providing a major role in the network routing as well as inventory management as well as in the supply management also. Now, in the case of healthcare, also RL is playing an important role. So, if you want an application where you want a personalized healthcare treatment for a particular person, or you want to provide a drug doses to a person on R basis or R basis, so you can make a robot which will give dose to the patient on a particular duration of time. So it is also helpful in the healthcare industry also. And the next one is finance and trading. As we all know that in the trading, in the business of trading or the stock market, if I want to manage my portfolio, or I want to manage that I should take a particular stock or not. So there also RL is playing a great role in terms of managing the portfolio. It's able to provide the algorithm which I can use for the trading purpose, as well as it is trying to minimize my risk when I am spending some amount in the stock market and all. Okay, so there also it's playing a great role, where we are considering where the agent will consider the historical data of previous stock markets. It will check the market condition and accordingly it will give me the decision that I should buy this particular stock in a particular day, or I should sell that particular stock or not. So in that way, RL is playing an important role. So these are the some of the application. The other applications are like NLP. So NLP is also application where RL is playing an important role. So if I want to translate my dialogue from Hindi to English or English to Telugu, there also I can use the RL agent, which can work as a translator between two people. If I know English and you don't know, you know Hindi, so I want to communicate with you, so I can use this translator to translate the content from one place to another place. The other application of RL is the recommendation system. So nowadays we all know that we are most of the time we are busy on the online platforms, and when we are doing any online shopping and all, so every time we are getting some recommendation of buying some clothes, some accessories as per your previous search. So there also RL is playing an important role, where it is giving you a personalized recommendation as per your previous feedback and the preferences. So agent will learn from your behavior, that you are interested in a particular beauty products, you are interested in mobiles or electronic gadgets, you are interested in watching movies, or you are interested in some particular content which is related to MLODL. Accordingly, it will start suggesting you different products. So that is also where RL is playing an important role. So these are the some of the application which comes under reinforcement learning. So I covered whatever the main applications where RL is playing an important role. So these are the application where RL is playing important role. The other is we have a machine learning applications where I can use machine learning. Okay. So if I'm talking about machine learning, we know that machine learning is a technology where we are trying to mimic a human behavior. Okay, where we are trying to, more than behavior, we can say we are trying to mimic the human intelligence in the machine. We are trying to make our machine to learn like a human and behave like a human and take the decision also like a human. So machine learning is playing a very major role in our today's society, we can say. So we can say machine learning playing an important role in most of the field in our day-to-day life. So there are some of the application where machine learning is playing a great role. So you can see in this diagram, we are saying that machine learning is playing a role in the predictive analytics, speech to text conversion or text to speech conversion. If I want to recognize a person image, there also machine learning are playing a great role. So if I'm working with some text related data, so I can classify data into different classes. I can translate data from one language to the another language, and others I can use machine learning as well as in expert system planning optimization, as also in robotics. So these are some of the applications where machine learning playing a great role. Now, according to this, we categorize our machine learning application into three basic categories. Okay, so one is image classification, other is text classification, and other is speech recognition. Under these three categories, I think most of the application will cover where machine learning playing a major role. So as we know, the first we are having this image, text, and speech. So if I'm talking about image recognition, so what you'll understand with image recognition. So I have given an image. I want to tell it is a boy or a girl. So this is nothing but a recognition. A model is able to tell me that particular given image a boy image or a girl image, or it's a any other animal image. Okay, so when we are talking about image recognition, it's your machine learning or deep learning is playing a great role in the field of image recognition. So we have a lot of application where we need face recognition. So if you talk about Aadhaar card verification, they'll take our photo and they'll try to recognize that the same person, we are the same person or not. So when we are talking about image recognition, we have multiple application. We can go with only classification, we can go with classification plus localization, we can go with object detection, or we can go with the segmentation. So you can see this diagram and you can understand there is a difference. So when I'm talking about classification, it's just saying me this is a cat. Okay. When I'm saying classification and localization, it means I'm giving where the cat available in a given image. So cat is available in this particular part of the image. So and top of that I'm saying the given image is a cat image. So I have done classification plus, as well as I have given a boundary box that where the cat is available in the image. So this is called classification plus recognition plus localization. Next is object detection. Object detection means if there is a possibility in a single image multiple objects are present. So in the given example, we have multiple animals are available in my given image. So I want to detect all the given objects which are present in the image. So you can see here it is giving a boundary box to every object or every animal which are present in the image. So object detection is nothing but it is able to detect all the objects which are present in the image. It will do the classification as well as it will have the localization also. The last one is segmentation. Segmentation is nothing but I'm trying to get the reason of interest in a image. Segmentation is I want the only part which I am interested. I have a full human photo, a person photo. I'm only interested in the face part. So the face part which I'm taking, that is called the segmentation. So in this case we have a whole image. In this image I am interested only on the animal animal image, animal part where animal is present, only in that part of the image I'm interested. So it's giving me a bounding box where all the animals are present, and as well as it's giving me the label of that. So this is nothing but your image recognition. So there are multiple application where image recognition playing a major role. You can use the image recognition in your attendance system. You are using image recognition in the Aadhaar card also verification. You are using image recognition in passport verification. So there are multiple application where image recognition is playing a major role. Same way, we have another application where machine learning playing a major role is text classification. So I have a huge amount of text is available. Now I want to classify that particular text. So there also machine learning playing a major role. You take a simple example. I got a mail. So if that mail is a spam mail, mail or ham mail, so I should have a model which will tell that particular mail is a spam mail, so it should be go to the spam filter, a spam folder, and if it is a ham mail, it should go to the inbox. So their text classification works. Okay. Same way we have sentiment analysis. Sentiment analysis is with your text, whatever text you have written, I want to know your sentiments. Nowadays we are getting a lot of feeds online, social feeds. So with your social feed, I can understand, I can understand that what is your mood today, how, what you are feeling. If you are posting a positive feed every day, I can understand you are you are a positive person who will who is thinking positively. If you're every day you are comment, you are giving some negative posts, so maybe your behavior is something different or something is disturbing you. So I can do sentiment analysis on your unstructured data also, as well as in the structured data also. So text classification is also the other application where machine learning is playing a major role. So this is all about the text classification. We can take a simple example of text classification here. Suppose I got a customer, I'm running with the customer support. I have a customer support. So I'm getting a multiple queries from different customer. Now I want to segregate those queries in a different folders. For example, I want to segregate all these queries as per their requirement. So my model or my machine learning model should be able to take these queries as an input, and it should segregate that yes, these particular queries are related to website, these particular queries are related to complaint, these particular queries are related to shipping. Accordingly, when I get the segregation, accordingly it should perform the further operation. So there also your text classification will play a great role wherever I'm having a customer support and you're raising ticket to solve your problems. Okay, so in most of the we can say in videos, text classification is playing a great role. Next is speech recognition. So there is nothing much to tell about the speech recognition, because in daily basis we are using the speech recognition. We always talk with Alexa and Siri to perform some tasks. Alexa, I want to listen this. You play this song for me. So how it is possible? Because Alexa is able to recognize what I'm saying. So Alexa will take that input. Alexa will take input from me. Automatic speech it will take. It will recognize what I'm talking, and it will give to the NLP model, and then it will be given back to me as a result. The same way, if I want to convert the result again into speech, that also possible in nowadays in the most of the applications. So speech recognition is again a major area where machine learning is playing an important role. So the best example of speech recognition is your Alexa and Siri. Okay, so this is all about the application of machine learning. So with this, I'm finishing the topic. Thank you so much. We'll discuss about mean, we'll discuss about median, mode, variance, standard deviation one by one. So these are start with the mean. So as you all know what getting error is present. Some of the features of giving all or any of or try to return something diamond same information but